Today we are going to learn engineering drawing introduction, and in this PPT, first one introduction, then geometrical constructions, scales, conic sections, special curves, orthographic projections, sections of solids, development of surfaces, introduction of solids, isometric projections, perspective projection, building drawing, drafting, hardware and software, and further developments. In this, first we are going to give the introduction of the engineering drawing. In this engineering introduction, drawing instruments and BIS, ISO drawing conventions, and first drawing sheet example. So in this PPT, we will give the introduction, first one introduction.
Learning objectives. After completion of the chapter, you will be able to identify various types of drawing instruments and their uses, classify drawing sheets and the different grade drawing pencils, draw the layout and title block on a drawing sheet, use the lettering and dimensioning techniques in common practice. Graphics, engineer's language. A picture is worth saying 1,000 words. Hence, drawing are used to visually communicate ideas, thoughts and designs. A drawing drawn by an engineer for engineering purpose is engineering drawing. Drawing is the universal graphical language of engineers, prepared, read, interpreted and communicated in its own way. Engineers must have perfect drawing skill and excellent working knowledge of engineering concepts. An inaccurate drawing may misguide the work person and ultimately affect the production. Drawing board. Drawing boards are made of well-seasoned softwood such as oak or pine. The board consists of a straight edge of wood made of ebony. This edge is called as working edge. The standard size of a drawing board as per BIS is 1444, 1963 are given in table. The D2 or D3 drawing boards are usually used in polytechnics and engineering colleges. Drawing sheet. The standard sizes of a drawing sheet as per BIS is 10711, 1983 are given in the table. The ratio of the width of a drawing sheet to its length is 1:√2. Also, the width of successive sizes are obtained by having the length of the preceding size paper. A2 size drawing sheet can be convenient for student usage. The drawing sheet should be tough and strong, and its fibers should not disintegrate when an eraser is used on its surface. T-square. A T-square is mainly used together with set square for drawing horizontal lines, inclined lines and perpendicular lines. There are two essential parts of a T-square, namely the stock and the blade. The blade is fitted with ebony or a plastic piece to form the working edge of the T-square along which lines are drawn. The stock is moved along the working edge of the drawing board. together at right angles. Mini drafter. A mini drafter is a device with two scales fixed at right angles to each other. It performs the functions of a T-square, set square, scale and a protractor. It can be easily and quickly moved to any location on the drawing sheet without altering the scales. It is a miniature version of drafting machine used in design departments. Pro circle. A pro circle is circular in shape. Its periphery is divided into 1.0 degree angular graduations that are used to mark and measure angles. It also has circular holes of different sizes that may be used to draw circles of specific diameter. Set square. Set squares are used to draw parallel and perpendicular lines. Set squares are made of transparent celluloid or acrylic and may also contain French curves. They are also called as triangles. One set square has 90 degree, 60 degree, 30 degree edge angles, while the other has 90 degree, 45 degree, 45 degree edge angles. Scales. Scales or rulers are devices with graduation marked on their straight edges for precise measurements. Scales are made of celluloid or cardboard. 8 types of scales are used as per BIS 10713 1983. The standard recommended scales are given in table. Instrument box. The instrument box contains the following instruments and accessories. Compasses, large compass and bow compass. Dividers, plate divider and bow divider. An inking pen, an inking bow compass, a lead case, one screwdriver. The instruments in an instrument box are made up of fine quality steel. Drawing pencils. Drawing pencils are of different grades. The HP pencil is a soft grade used for drawing thick lines, border lines, letterings and arrowheads. The H pencil is used to draw finishing lines, visible lines and hidden lines. The 2H pencil is a hard grade pencil used for drawing construction lines, dimension lines, center lines and section lines. Other grades are used for artistic applications. Eraser. An eraser is a good quality rubber that is used to erase unwanted lines, arcs, etc. from a drawing. Clips. Drawing clips are used to fix the drawing sheet on the drawing board. They are made of nickel-coated steel. Cello tape or adhesive tape may also be used in place of clips to fix the drawing sheet on the board. Sharpener and emery paper. A pencil sharpener is used to sharpen the pencil tip. Emery paper, 120 grade water emery, is used to obtain conical or chisel tip lead of the pencil.
Now next one, BIS ISO drawing conventions. In this layout drawing sheet and line types, lettering in drawing, dimension methods and arrows. So first we will discuss layout drawing sheet.
Layout of drawing sheet. It is the standard arrangement made to ensure that all necessary informations are included in the drawing and also essential features can be readily located. Border lines, filling margin, title block.
This is the way of preparing of drawing sheet. See once again.
Layout of drawing sheet. It is the standard arrangement made to ensure that all necessary informations are included in the drawing and also essential features can be readily located. Border lines, filling margin, title block. BIS and ISO drawing conventions. The International Standard Organization, ISO Geneva, has formulated international standards for engineering drawing. The Bureau of Indian Standard, BIS, previously known as Indian Standard Institution, ISI, has adopted the ISO standards. ISO standards are applicable to the following topics: layout of drawing sheet, line types, lettering, dimensioning methods, arrows. Line types. In engineering drawing, every line has a definite meaning. Various types of lines are used to represent different parts or portion of an object.
See, this is a continuous line and continuous thin, draw freehand, continuous thin with zigzag and shorter dash hidden lines, and long chain thin. This is the long chain, thick at end and thin elsewhere. So this is the line types representation.
Lettering. Lettering plays a major role in engineering drawing. It indicates details like dimensioning, name of the drawing, etc. The use of instruments for lettering is not advised as it will consume more time. Freehand lettering should be used instead. Proper strokes should be used for faster and proper lettering.
So in this next we will discuss the rules of lettering and vertical lettering, inclined lettering. Now first we will going to learn rules and its features.
Rules and features. Lettering in a drawing must be of standard height. The standard heights of letters used are 3.5 mm, 5 mm, 7 mm and 10 mm. Generally, the height to width ratio of letters and numerals are approximately 5:3. The height to width ratio of the letters M and W are approximately 5:4. Different sizes of letters are used for different purposes. Main title 7 or 10 mm, subtitle 5 or 7 mm, others 3.5 or 5 mm. The essential features of lettering used in engineering drawing are that they should be legible, uniform, similar and rapidly printed. Single stroke letters are the simplest form of letters and are generally used in engineering drawing. The two types of lettering practiced are vertical lettering and inclined lettering. Vertical lettering. Vertical lettering is upright, that means 90° to the horizontal. Both uppercase or capital and lowercase or small letters are used. Inclined lettering. Inclined lettering has letters inclined at 75 degrees to the horizontal, and as in for vertical lettering, both uppercase and lowercase letters are used.
Let us take an example H. A, B, C, eight, X, K, T, one, nine, E, Z, F. Three, 4, 5, 6, 7, 8, 9. Now, previous one, alphabets, some of the alphabets. L, M, height to width ratio is 5:4. N, Now let us continue the previous engineering drawing, which is in which introduction. So they mainly engineering students can use engineering drawing, and which indicates is engineers and technologists. Engineering drawing is the more important in the day-to-day life, which will improve the thinking abilities and imaginary powers of the student. So it is that's why engineering drawing is a very essential. And engineering drawing is represented in a two-dimensional way of a three-dimensional object on a drawing sheet. Also is a graphical representation of known drawings. Drawing is prepared in
one country may be utilized in any other country, which is a standardized one. That's why we can call it as a universal language of engineers. So now in a modern engineering produces enormous number of articles. Each article is a first design and represented in the form of a technical drawing for the benefit of all the persons involved at all stages. Each item is indicated on the basis of drawing. Therefore, drawing must be clear, correct, accurate, and all shall only be one interpretation. So first of all, we are already discussed some of the engineering drawing importances, and now let us what is the need of preparing an engineering drawing as per standards. So in all three types of transactions like exchange of goods, exchange of services, and change of information, technical drawings form an essential component. So goods, engineering component in national and international trade always need to be accompanied by service diagrams and other technical drawings illustrating goods, engineering components, their assembly and use. Similarly, exchange of service may involve consultancy work or the design or an assembly in one unit or construction. In such cases, technical drawings is important means of communication, instructions, advices. Exchange of services may involve information, especially where different languages are involved. The technical drawing can clearly ambiguous can or help to resolve problems in communication by spoken or written words across language barriers. To achieve these objections, can call it as a IS 691 Code of Practice for General Engineering Drawing. It is originally issued in 1955 and revised in 1960 and 72. Since the publications said standard consideration progress has been achieved in the field of standardization of engineering drawing by mutual agreement between various countries. It has the shape of home standards. The growing international cooperation, introduction of foreign language technology, or export of technology has necessitated to develop internationally unified methods and symbols, which require to understood by people at various stages, possessing various intelligent levels. At present, Bureau of Indian Standards (BSc) has introduced a new standard called SP 46 1988 for drawings. So, which already discussed all these importances. Now, first, what is the role of engineering drawing in education? By studying engineering drawing, a student becomes aware of how industry communicate the technical information. Engineering drawing teaches the principle and accuracy and clarity in presenting the information necessary to technicians to produce products. It develops imagination that is so essential to produce a successful engineer. Apart from being a communicate language in engineering application drawing, plays a link role in all the engineering subjects. Engineering education with all the inputs to understand techniques and technologies require the clarity in understanding various concepts involved. Product process in every field of engineering like civil, mechanical, electrical, etc. All engineering. This can be better achieved by illustrating in the form of sketches, diagrams, figures. Now we are already discussed engineering drawing instruments previously, like all these, like drawing instrument box, drawing board, mini drafter, set squares, protractor, set of scales, French curves, drawing pencils, drawing paper, eraser, erasing shield, tracing paper, oblique cloth, T-square, drafting machine, etc. All we are used in a engineering drawing. Just we observe compass, most important is lines drawing. So there is so many representation, different types of representations of lines here. So the continuous thick line, which is used to represent for general purposes visible outlines and visible edges. Similarly, B is a continuous thin, straight or curve. The imaginary lines of intersection, dimension lines, projection lines, leader lines, hatching outline of revolving sections in place, short center lines. Similarly, continuous thin, freehand. The limits for partial or interrupted views and sections. If the limit is not a giant thin. Similarly, a continuous thin line that with zigzags. This is also used for limits of partial and interrupted views and sections. If the limit is not a chain thin line. Similarly, a dark dashed thick line. It is used for hidden outlines, hidden edges, hidden outlines, hidden edges. Similarly, dashed thin lines also. A chain line. It is used to represent center lines, lines of symmetry, trajectories. Similarly, chain thin. Which is a cutting planes. Similarly, chain thin, and it is used for indication of lines or surfaces to which a special requirement applies. Chain thick, a dashed chain thin double dash. It is used outlines of adjacent ports, alternative and extreme positions of movable ports, centroid lines, initial outline prior to forming K5 ports situations in front of the cutting planes. So like this, the engineering drawing lines are represented, which are used for special purposes. And while drawing all the line thickness and the pencil drawings, which are all a specific purposes, like thickness of lines are varied accordingly to the drawing with the ink or pencil. All lines should be dense, clean, uniform, etc. There are sheets sizes also were already discussed in detail by designing defining all the sheets which are used at particular special purposes. There are lettering some guidelines. So in the guidelines for lettering, as previously discussed some of the points and some more enhanced, now we will discuss. The height of a capital letter is taken as a base of dimensioning. Similarly, the two standard ratios, that is d by h, that is 1 by 14, 1 by 10, are most economical as they result in a minimum number of line thicknesses as illustrated in tables 3 and 4. Here we'll see in the screen. Here are all examples. So similarly, the letters are all were already explained in a previous one. So this is the table how we can use the thicknesses, and just you observe a table 2. The lettering height is h, which is a capital, that is 14 by 14 h is dimension 2.5, 3.5, 5, 7, 10, 14, 20. These are all lettering dimensions which will be used, like h is a height, and height of lowercase to letters without a stem or a tail, these will be used. Similarly, table 3 as previous one. These are all the example which were already drawn, which were already given the information how to draw. Just you observe all these. Now it is the completion of the introduction of the engineering drawing. We will use engineering drawing, and books are mainly it will be referred for engineering drawing is a